Hello, Legacy Sabers, Marsh here. So today we're going to be talking about sorting algorithms that can be completed on either an array or an array list. So ultimately, our essential question today, what algorithms exist to sort data inside of an array or array list? Now, first thing I want to say though, if you are taking the AP exam, be aware that you're not required to know the code or write it out. However, what will happen in a multiple choice setting is they will give you a question that's based on sorts. And if you can recognize the code, you're going to be much faster at that multiple choice question. If you're not taking the AP exam, it's just good to know what different algorithms exist and which ones are the best for what situations. So the first one that we're going to talk about is the selection sort. The selection sort I like to call the search and swap algorithm. Steps that we're going to do. First thing we're going to do is we're going to find the smallest element in the array and exchange it with the first element, the guy that's in index 0. Then we're going to find the smallest element in the middle array, swap it with A1, the second element. And we're going to keep doing this until we are completely sorted. Okay, so basically you're finding the smallest, swapping where you have not done information yet. So here's an example of our selection sort. Our unsorted array is 4, 2, 5, 1, 3. So first thing I'm going to do is I'm going to identify the smallest value, which would be a 1. So what's going to happen is the 4 and the 1 are going to swap places. So I'm going to make note of that. And then what I'm going to do is I'm going to just rewrite all the other ones. And then I like to do this, a little line here to show that I've already swapped this one. This one's the lowest. Next thing, I need to find the next lowest number, which in our case is 2. The computer doesn't know that, so it literally is going to take the 2 and swap it with the 2. So we're just going to rewrite. Okay, but that means 2 is done sorted. So now we're going to find the next smallest number, which would be 3. That means the 3 and the 5 are going to swap places. Oops, that should be a 2. 4. 3 is now, no, it's done. 4, we're going to make sure, yep, 4 is the smallest number. And since 5 is the last one, it knows that it is sorted. Okay, so like I said, it's a search and swap. You're looking for the one that is the smallest. You're swapping it with where you currently are. In code, this is what the selection sort looks like. So notice we have a for loop going through the entire array. We are finding the minimum element, just like we said, and then we're swapping the values. So things to look for if you're looking at code and you're wondering, is it selection sort? This is the part that I would look at. So if I'm looking at a set of code and I'm wondering if it's selection sort, I'm looking for the minimum value selection. Okay, I'm looking for this because if it's the minimum value, then I know that I'm looking at selection sort. The next kind of sort that we might be looking at would be an insertion sort. Insertion sort is a sorting algorithm you naturally use when you're playing cards. So when you're holding cards in your hands, normally what you do is you pair the 2s, then you do the 3s, then you do the 4s, right? You like sort them. And every time you get to a new card, you sort it into the sorted side of your hand. So what we're going to do is we're going to think of the first element, a sub 0, as being the sorted with respect to itself. So it is a sorted value. Then what we're going to do is we're going to think of the array as 2 parts. There's sorted and there's unsorted. And every time I get to a new value in the array, you're going to move it into the sorted side, putting it in its perfect condition. In order to place the new items, some elements may need to move down to create a new slot. So here's what's going to happen in our insertion sort. So first thing we're going to do is we're going to assume that 2 is sorted. Yes, 2's in the right spot. Then we're going to go down to 5, and we're going to put 5 in the correct spot and related to 2. Well, 5 goes there, right? So after the first pass, it's going to look something like this. And the sorted and unsorted side, so this is sorted, this is unsorted. 1 is the next part that needs to join the sorted area. 1 would go before 2, right? So I'm going to put a 1 there in its respective place. And then I'm going to make note that 1, 2, and 5 are in the sorted side of my array. 4 is the next value, so he's got to go into the sorted area and put him in the right spot. So I'm going to do that. Okay. 3 is the last one. He needs to go in his respective spot. And I have now sorted the numbers. So literally, when you encounter a new number, you're going to make sure that you put it into the sorted side of your array in the correct order. Here is the code that you will see in a insertion sort. So we have a loop going through the entire array. We say the first one is correct, and then what we are doing is we're moving things with this while loop, one in front of the other, making it the right spot, and then we're putting it in the right spot. Best way to identify an insertion sort is this while loop. Insertion sort is the only one that theoretically needs to implement a while loop. So it's most common that you'll see a insertion sort being used to make with a while loop. So that is, how would I notify that it's insertion sort? How would I look for that? I'd look for a while loop. The next one is called a bubble sort. This is called the heavy goes to the bottom algorithm. So ultimately, what you're doing is you're just comparing pairs of items, next door neighbors. And if they're out of order, you're swapping them. After one pass, we're assuming that the last number in the array has sunk to the bottom. And all the lighter values will float to the top. That's why it's called the bubble sort. Here is the bubble sort. As you can see, this one takes a lot longer than all of its other sorting algorithms. That is the unfortunate part of the bubble sort, is that we do actually have quite a bit of work when it comes to bubble sort. So, first thing, we're going to take a peek at, is 5 and 4 out of order? Yes. So we're going to flip them around. Okay, now we're going to check the 2 and the 5. They're out of order. So I'm going to flip them around. Notice what I'm doing. I'm circling the pairs I'm checking. That helps me pay attention to what I'm doing. Okay, the 5 and the 1, they're out of order. Flip them around. And then the 5 and the 3 are out of order. Flip them around. Now what you can assume is 5 is sorted and we don't have to continue. We don't have to check 5 anymore. It's hit the bottom. It's got to be the biggest number. So now we got to go back up to the top. 2 and 4 are out of order, so I got to put them back in order. Now I'm going to be looking at the 4 and the 1. They are out of order, so I got to put them in order. Remembering that the 5 is done. Now I got to check the 4 and the 3. They're out of order. Put them in order. And now since the 4 has hit the bottom, we can assume 4 has been sorted. So we're going to kind of finish that. And back to the top. 1 and the 2, they're out of order. Okay. 2 and the 3, they're not out of order. Oh, first time. So we're just going to rewrite. And now, since the 3 has hit the bottom, we're going to assume that it's been sorted. Now I got to check the 1 and the 2. They're not out of order. And since 2 is on the bottom, we can assume he is sorted. And 1, of course, is sorted by itself. Whew. As you can see, bubble sort is not the most efficient algorithm to accomplish sorting, just because it takes so many different passes, so many different things to do. However, in code, the bubble sort is the easiest code to see. Bubble sort, best way to notice what's happening here is literally this if and the swap on the inside. So, and the double for loop. It's the simplest algorithm. That is the best way also to look at bubble sort. But what I'd be looking for in a bubble sort is I'm looking for this double for loop right here. And I'm also looking for this neighbor check of j and j plus 1, or index and index plus 1. Bubble sort is the easiest algorithm to write, so that is why a lot of people write bubble sort, because it is the easiest to write. However, when we talk about efficiency, bubble sort is the least efficient, especially if you have a lot of data. Last one is merge sort. So what merge sort is you're going to break it into pieces and then rebuild it correctly. If there's more than one element in an array, here's what you're going to do. You're going to break the array into two halves. You're going to merge sort the left half, you're going to merge sort the right half, and then we're going to merge the two subarrays into a sorted array. A main disadvantage of the merge sort is that you use a temporary array. Literally, this is break it into, you have individual pieces and you're going to put it back together correctly. So here is our example. We have the numbers 5, -3, 2, 4, 0, and 6. So what I'm going to first do is I'm going to cut this in half. So I'm going to make an array of 5, -3, and 2, and another array of 4, 0, and 6. And then we're going to merge sort the left half. So we're going to forget this right half exists for a bit. We're going to look at this one. So I got to cut it in half. Now notice, you're like, Marsh, does the -3 go with the left or go with the right? Honestly, it depends on how you wrote your code. Consistently, though, you will find that I would divide 3 by 2. You would get 1, right? Because of our decimals not coming out when we divide integers. So I will be cutting at -3. So what I'm going to do is I'm going to make it so that I have an array of 5 and -3. 2 is on its own now. And then I got to merge sort this guy again. So I'm going to break those guys into pieces. Okay. Now I can start putting them together. So I'm going to start putting the guys that most recently broken. I'm going to break them and put them back in the right order. So -3 and 5 are going to go together. Like that. And then the 2 is going to go join in the right spot. 2 and 5, just like that. Now, I have sorted the left. I now need to merge sort the right. So again, 4 and 0 are going to join their own little spot. 6 is going to be in his own little world. The 4 and the 0 get to break apart. 0 and 4 go together. And then they all join back together in the right order. Then what's going to happen is from each array, you're going to take it. So you're going to be like, all right, -3, you go first. Then it's going to check it's either 2 or 0. Okay, 0, you're going to go next. Then it's going to look, okay, 2, you go next. And it's going to compare and put them in order into one big array, just like that. Whew. Merge sort, like I said, literally it is break it until it's correct. Now you're thinking, well, Marsh, that's not a bad algorithm, but how does that look? Merge sort doesn't look terrible on its first look at its code, but notice there are some functions, some methods being called. Sort is calling itself. Weird, right? Literally, you are calling itself. It's called a recursive method. We're going to talk about that a lot later, but you are literally having sort call itself. And then there's a method called merge. Those methods look like this. Okay, that is the merge section of the function. Scary, right? Holy buckets. So if I'm ever looking at an array and I'm wondering, is this a merge sort? I'm going to tell you guys. Merge sort, you're going to 100% know it because literally it is the longest code in all humanity to write. However, it is pretty efficient of an algorithm. We talked a little bit already about the benefits and the drawbacks of each sort. Bubble sort is definitely the least efficient algorithm. There are other algorithms that do exist. However, bubble sort is probably one of the least efficient of all of these. Insertion and selection have about the same efficiency. And then merge sort is efficient. However, as you saw, the drawbacks of the code writing alone of merge sort. Plus, it also requires another array to do its job. So those are a couple of benefits and drawbacks. Why would you use one over the other? I would say a benefit of the bubble sort is it's the easiest code to write. If I had to sort an array, I probably would write the bubble sort just because I could think through that code. The other ones, I would probably have to look them up just to see what they look like. But keeping that in mind, some of them do have benefits and they also have some drawbacks as we're looking at each of those codes. And that is the end of our video. I hope you enjoyed learning about sorting algorithms today and putting numbers in order. I will see you later, Sabers.